So in our last video, we talked about our graded potentials, and we said they could produce an action potential, so they can excite the cell to reach an action potential, but I actually didn't tell you the whole story, because not only can they excite an action potential, or excite the cell to action potential, they can also inhibit it. How do they do this? Well, this is the slide that we ended with last time, and I basically showed you that the stimulus caused an upward movement in the membrane threshold. But what happens if that stimulus actually causes a downward deflection? It would mean that we moved further away from threshold, and therefore that an action potential was less likely. Well, how does this happen? Well, we've already said that our green neuron here allowed sodium to enter into the cell to make the inside of the cell more positive. And we mentioned, of course, that it released neurotransmitters which bound to the chemically gated sodium channels. Well, the opposite can happen down here. This red neuron is also going to release neurotransmitters, but instead of binding to chemically gated sodium channels, this time these neurotransmitters are going to bind to chemically gated chloride channels. So here we've got our binding, allowing the channel to open, but we're now going to have chloride come from the outside of the cell, inside of the cell, therefore making the inside of the cell even more negative. So in this case, we're now inhibiting any further communication. So up the top, with the sodium entering, we cause excitation in the postsynaptic neuron. Here's our synapse here. Anything after that is called the postsynaptic cell. So we cause excitation in our postsynaptic cell, and this is called an excitatory postsynaptic potential, or an EPSP. Basically, we had further depolarization of the cell. The cell became less negative, more positive, brought it closer to the threshold of -55, and increased the chances of action potential. But if those neurotransmitters act on our chloride channels, for instance, instead of our sodium channels, we have an inhibitory response. We cause inhibition in the postsynaptic cell, thereby leading to an inhibitory postsynaptic potential, or an IPSP. This meant that the graded potential hyperpolarized the cell. It became even more negative, even more polarized. And because it was more negative, it was even further away from threshold. So nowhere near the -55, now perhaps at -90 or -100, and therefore much, much less likely to achieve an action potential. So if this is what happens, you can then quickly see that it's the excitatory postsynaptic potential, the EPSP, that's going to move the dial this way from resting membrane potential, rather than inhibitory one, which will move it that way. So if the graded potential is excitatory, as is the case up here, and large enough, as is the case with the graded potentials, it will cause an action potential, and that is what we'll talk about next video.